Binomial expansion. Okay, this one was tough. So you've got x minus 1 over x squared to the 12. Now, you know from the binomial expansion that you're going to be using coefficients from the binomial Pascal's triangle, and we're going to be looking for coefficients on the 10th row, the 12th row. Now, you could write out these. There's not really much point because there is a shortcut to getting these. Obviously, you can go into your calculator and you can go for, let's come back into calculation mode. You can do 12c naught. Anything c naught is obviously 1, and then 12c1, which is always going to be 12, and then 12c2, 66. And so if we use that, we can get the binomial expansion, and we'll get 1, 12, 66 for the naughth one, first one, second one, and that will go on to the 12th one, which will be 1, and the 11th, so this is the first, so naughth, first, second, up to the 12th. The 11th one will be 12 as well, and the 10th one will be 66 as well because of the symmetry, and there'll be ones in between. And then we could look at maybe if we start with descending powers of x, so we have x to the 12, x to the 11, x to the 10, and so on, down to x to the 2, x to the 1, x to the 0. X to the 0 we don't need to put there, right? And then ascending powers of 1 over x squared. So this will have 0x squared, this will have 1 over x squared, so it's minus 1 over x squared, isn't it? Yeah. This will be minus 1 over x squared squared, and then up here we'll have minus 1 over x squared to the 10, minus 1 over x squared to the 11, and minus 1 over x squared to the 12, because that's how the binomial expansion works, right? The sum of the powers for each one is always 12. So this is 12 and 0, this is 11 and 1, this is 10 and 2, and they'll go 9 and 3, 8 and 4, 5 and 7, 6 and 6, etc., down to 2 and 10, 1 and 11, and 12. And then the binomial numbers, for the Pascal's triangle coefficients, will come in the middle, and this will be the full expansion if we chose to write it all out. But luckily, we don't need to write it all out. That said, we've got a rather awkward question. We're looking for the term which is independent in x. Now, what that means is that at some point, the x's and the x squareds will cancel, the 1 over x squareds will cancel out. So this one's x to the 12. This one is x to the 11 times 1 over x squared, which is x to the 9. This is x to the 10 times 1 over x squared squared, which is x to the 10 times x to the minus 6. This is x to the, mine's gone blank. I think I said something wrong there. Sorry, 1 over x squared squared is x to the minus 4, sorry, so that's x to the 6. And you'll notice that these powers are going down in threes. At the very end, we'll have 1 over x squared to the 12, which will be x to the minus 24, x times 1 over x squared, which will be x to the minus 21, and x to the minus 18. Now, somewhere in the middle, going from 12, 9, 6, down to minus 18, minus 21, there will be a term which has x to the 0 in it. And so the question is, where is that? Now, you can probably see from the pattern where it's going to turn up, but we can be a bit more systematic about it. We know that it's x to the something times minus 1 over x squared to the something. And we know that this number and this number have to add to 12. And we also know that because there's x to the minus 2 here and x here, we're going to need twice as many of these to cancel out with these. So we need a ratio of 2 to 1 that adds up to 12. It's going to be 8 and 4. And you would have got that obviously by carrying on the sequence, because this is going x 12, 11, 10, 9, 8. And so we would have had x3 and then finally x0 here, which would have been not the third but the fourth term. So the fourth term has x to the 0, and it's got x to the 8 minus 1 over x squared to the 4, and it's also got whatever the fourth number in the 12th row of Pascal's triangle is. So you could write out, and you could keep going, and we could get to the fourth row. But there's a very easy way of doing it again. It's just 12c4. In the same way, this is 12c0, 12c1, 12c2. So if we do 12c4, we get 495. And so the term that is independent in x is going to be 495 times this to the 8 times this to the 4. And because this is 1x and this is minus 1 over x squared, it's going to be 495 times 1 to the 8. If this were 2 or 3, we'd need to include that. That'd be 2 or 3 to the 8. And again, times minus 1 to the 4, which is just 495. I only include the 1 and minus 1 in case this were 2x, or this were minus 3 over x squared, and then this would be 2 and this would be minus 3. Now, we have to expand 2 plus px to the 7 in the next one. So, in order to do this, px cubed. This time we're going to need to expand a few more terms. So we're going to have, again, we're going to have the 7th row of Pascal's triangle, which I've helpfully just started writing out up here. Oh, it's off screen slightly, but that goes 1, 7, 21, 35. We don't need any more of those, in fact. And again, you could just do 70, 0, 71, 72, 73 on a calculator. We don't need any more of those because we're only doing the terms up to x to the 9, which will be this cubed. So the first term is going to be 2 to the 7, then 2 to the 6, then 2 to the 5, then 2 to the 4. And these terms are going to be px3 in ascending order. So px cubed to the 0, px cubed to the 1, px cubed squared, and px cubed cubed. It's all getting a bit cramped here, sorry about that. And we're adding those together. Now, you will see that we're talking about the coefficient of x to the 9, which is going to come out of x cubed cubed, and the coefficient of x cubed, which is going to come out of this one. So we only really need to look at these two terms. 7 times 2 to the 6 is a big number, and I'm feeling a bit rusty, so I'm going to actually type that on my calculator this time. 448. So we've got 448 px cubed, and over here we've got 35 times 2 to the 4, which is 560 times px cubed cubed. So this is going to be 560 times p cubed x9. And we know that this one is 20 times bigger than that one. In other words, if we multiply this by 20, we will get the same. Now it does say coefficient. So if we're just looking at making the coefficients equal, we can ignore the x cubes now and the x9. Because it's the amount of x cubed is the coefficient and the amount of x9 is the coefficient. So 20 times 448p equals 560. Now there's a 20 here and a 560 here. So let's divide through by 20. So we get 448p equals 28p cubed. And then we can divide through by 28. We get 16p equals p cubed. And then we can divide through by p. Obviously p is 0 is a, whoops, I'm off screen. P is 0 is a solution to this, but that doesn't matter. 16 equals p squared. And we're told that p is a positive constant, so we don't need to go for plus minus 4. We can now just say that p is 4. Very nice. Okay, on to the nasty parts at the end. I'm going to pause and